The core of the motor, including the stator and rotor of the motor, are made by stamping and laminating. The main material used is silicon steel sheet. The silicon steel sheet is coated with an insulating coating to isolate the connection between the upper and lower pieces. So the ideal core should be like this. But in order to fix the sheets, traditional lamination fixation, welding, and riveting are used. These processes more or less will make the upper and lower silicon steel sheets contact, forming a loop, which makes the snail have a longer path, increasing the snail loss. Snail loss will reduce the efficiency of the motor. Therefore, in motor design, reducing snail loss has become an unavoidable problem. What is snail loss? According to Faraday's law of electromagnetic induction, when an alternating magnetic field passes through a conductive material, an induced electromotive force is generated inside, which causes electrons to flow inside the conductive material, forming a closed loop. This is eddy current. Snail will circulate in the material continuously, causing the temperature of the material to rise everywhere, resulting in energy loss, which reduces the efficiency of the motor. So how to reduce logistics loss? There are many factors that affect logistics loss. One of the important factors is the thickness of silicon steel sheet. The thicker it is, the greater the logistics loss. The silicon steel sheet of current mainstream motors is between 0.5 and 0.2 millimeters. But with the development of technology, the thickness of silicon steel sheet is also constantly decreasing. But when the thickness is small to a certain extent, welding and riveting processes, it is difficult to achieve effective lamination. So, the bonding lamination process has become another choice. Currently, there are three main processes: vacuum static process, self-adhesive process, dispensing process. The vacuum refining process is to stack and press clean silicon steel sheets into a flat plate and put it in a vacuum tank. After removing all the trapped air, it enters. Glue is used to fill all the gaps between layers. Then remove the excess residual glue. Then clean the laminated surface. Finally, heat and cure to shape the core. Cut it into the required core shape when needed. Self-adhesive lamination is also called full contact lamination. It is to coat a layer of resin glue on the silicon steel roll. After baking and drying, forming a micron-scale dry glue film attached to the dry roll. During the lamination process, use these dry rolls with dry glue films attached. Cut out the required shape of silicon steel sheet, then heated, laminated, and cured to form the core. There are two types of dispensing lamination. One is to use the principle that adhesives and accelerators. To achieve rapid curing, coat the promoter on one side of the silicon steel sheet and glue on the other side when laminating. The upper and lower surfaces achieve contact with glue and promoter to quickly cure and form the core. The other is on the stamped silicon steel sheet. Glue is applied by dispensing or coating, then laminate, and finally cured to form the core. It can be seen that the bonding and laminating process not only does it not damage the insulating coating on the surface, but also not affected by the thickness and shape of the steel sheet, effectively reducing logistics losses. In addition, the adhesive can also disperse external stress as well. In the environment where the motor is impacted or vibrated, it can maintain a stable working state. Thank you for your attention.